Boop. Any vote for hardest problem? Out of curiosity, any of these you think was the hardest? Yes? Three? Three. That's what I thought might happen. That one kind of depends on if you remember. Yes?
Maybe D and A
D and A.
on the first one. Or actually all of them.
Yeah, well, my calculus class, I said, what was the hardest one? They said, the sheet. Yeah, okay, thanks for breaking that down. All right, so what's this problem all about? In fact, I mean, it never disappears, but that one's really in your face. What's behind that problem? I heard somebody say it over here. Yeah, PEMDAS. What does that stand for? Please excuse my dumbass son. That's right.
Oh, that's the first time I
Or-
ever in middle school.
Do you remember Dear on Sally?
Yeah.
And then somebody else told me, dumbass son. I was like, I'm going to steal that. And then in class a while back, they came up with this themselves. They said, please excuse my deficient algebra skills.
Oh my god.
So that was them. I mean, I'm not quite that evil. But here's the problem, real quick. I have seen this with my own eyes. I have seen, now of course we write this, yes? I may not do what it's about to do. We could write it like this. Which one's easier to say? The top. Which one makes you sound drunk if you try to say it? The bottom. Now, either one of those would work, to be honest. And I'm not sure if you guys understand what I'm getting at. So neither one of those is the way we should write this, because I have seen with my own eyes teachers teaching that multiplication comes before division, which is false. It is so wrong, and it makes me cry a little bit.
I do like PE.
Yes,
M
yes.
slash D.
No way. This is
And then
exactly what I do.
A slash D.
I do like that.
Wait,
Like this?
yeah.
Yes. Because this is definitely parentheses first. No question. What's inside parentheses has to be done first, yes? And then it's exponents. And then it's multiplication, division as it comes. And then it's addition, subtraction as it comes. Very quickly, do you guys get this reference? There is no spoon.
Yes.
Yes, thank you. That's from the matrix. So there is no division. There's multiplying by the reciprocal. Yes? There is no subtraction. There's adding the additive inverse. You guys kind of with me? So multiplication, division, they're on the same level. Neither one comes before the other one. They just come in the order they're in. So here's a beautiful example. I don't go into Facebook very often. And some of you guys probably never do because it's mostly an old person thing. But I often see stupid things like this that make me cry a little bit. There's this, somebody posts this, and there's this huge argument over what the answer is. Oh, now, what are the only operations in that statement, in that expression? Multiplication, division. Neither one of those comes with any precedence. Neither one of those is more or less important. You just do it in the order they come. So the answer is not 1. What is 4 times 4? 16 divided by 4. No, 16 divided by 4. 4 times 4. Yes. And here's the key way to look at this. What is the only number up there that you're dividing by? Divided by 4 times 4. You guys see that? And what's the other way to write division? Over. So if I rewrote this, it would be 4 times 4 divided by 4 times 4. Do you guys see that? Okay. But you guys, that is tricky. I do get that. And one major reason it's tricky is when we see this, we often think about it as one big ass division bar, yes? But it's only that if I collect this and collect that, yes? You guys with me? So I really want you to be consciously aware that these two come as they show up. Neither one is more important than the other one. Okay. The most common mistake I see is people leave division till the end, but that doesn't make any sense. What's at the ass and the PEMDAS? Addition and subtraction, yes? Okay. Sorry, yes. So when I do this, I heard a lot of the good shit. I heard people saying, take care of this part first. Well, what is, of course, the very first thing you have to do? Yeah, what's inside parentheses? -1 minus 2 is?
-3.
-3. Okay.
So then it's
Let me see if I can just try to stop dying. Huh? Sorry. So let's see, we got 3 minus 5 times -3 cubed divided by 9 Oh my God, Jeff. Times 3. Oh. I'm an old man. I got really shit. Okay. Now, I heard somebody, what's the next thing? We got everything in parentheses done.
Negative 27.
Huh? Do it again.
Exponent.
Exponent. So what's negative 3 cubed?
Negative 27.
Good. 3 minus 5 times negative 27. The most common mistake I see here is people will put 27 here. That is not fair. I'm divided by 9, not divided by 27. You guys see that? I know this is a really kind of basic level idea, but it's one that's easy for every level of math I teach to make mistakes about. And some of it is because they were taught wrong, which is horrific to me that there's math teachers teaching people wrong. This is kind of gross, yes? What's the next thing I should do? Oh, actually, let me say it this way. What is the last thing I should do? Yes. The 3 minus. That 3 is just kind of waiting. 3 minus, we don't know yet. So it's got to wait. Subtraction is where? At the end of PIMDAS, yes?
What?
So what do I do next?
3 plus 135 is your multiple.
Yes, good. Negative 5 times negative 27 is positive 135. And here's evil Jeff not letting you use a calculator. But I'm going to show you something you could have done. What's 135 divided by 9?
15.
Okay, good. Real quick, do you guys know how to tell just by looking at it that 135 is divisible by 9? Yes.
You add up all the numbers.
Yes. How many people know that? What do you get when you add 1 plus 3 plus 5? 9. If you add up the digits in any length number and they add up to a multiple of 9, it's divisible by 9. Does anyone know that? You didn't know?
I know by my fingers.
Now, part of this could be you forgot. Part of this, I think, is there's a bit of a movement towards just using calculators instead of knowing certain basic numerical facts. And as a human, you should be upset. You're like, share that shit with me. Right? We know it as a human species. We have this knowledge. We're supposed to share it. There's rules for a lot. Like, okay, 2 is easy. How do you tell something's divisible by 2? Even. How do you tell something's divisible by 3? You add up all the digits, and if it's a multiple of 3, and it makes sense because 9 is a multiple of 3, so they have a very similar rule. What about 4? Does 4 go into 100? What 4 quarters is what? 100. So 4 goes into 100, which means 4 goes into any digits, any number where the last 2 digits are divisible by 4. So 8,978,429. What did I just say? 428. The last 2 digits are 28. 4 goes into 28. 4 goes into the whole number. Yes? You guys kind of with me? Yeah. So you should be a little upset if you think you've never heard of these things. Okay. All right. I'll stop. And you all know 5. 5 is easy. 5 is okay. Oh, I'm not done with this. So 135 divided by 9 is 15. 15 times 3 is 45.
Oh.
And then 3 plus 45, Jeff, is 48. I get so close. Now, notice part B. Is part B an equation?
No.
Very obviously because it's missing an equal sign. Sorry, I can make this thing lean, but where am I at? Oh. So I'm not going to have to solve for x and y, and I couldn't because I have 2 variables there anyway. There's no way I could kind of tease out either one. All this problem is like terms. But what's the first thing your eyes should be drawn to? There's 2 things I would give here. Yes. That means you have to do what? Distribute. And what are you distributing?
The negative 2.
Negative 2. Good. So I got 5x minus 3y plus 10y
Minus 2x.
minus 2x. Plus 10y. What happened? Oh, I left it y. Thank you. And now you just identify, and what I normally do is, I'll say, here's my x's, here's my y's. I just underline them in weird ways, so I can kind of visually group them without actually having to rewrite the whole damn thing. And then I get how many x's?
3x.
3 x's and how many y's?
17.
Yeah, 20 minus 3, 17, right? Got the 2 10s and the 3. You with me? Let's see if I remember what I just said. Here I go. Okay. Here I go, doing math again. Is everybody with me so far? You gotta let me know if something's not making sense. If you made a mistake and you see why, that's good. That's fine. And I'm human. I make mistakes, dear God, as Maria just pointed out. What's part C all about?
Getting a common denominator.
Yes, common denominator. The most common mistake I see is somebody will tell me it's 2 over -2. Where'd that come from? They'll tell me the answer is -1. You guys see where they came from? What did they do? They just kind of subtracted straight across. No way in hell this should work that way. In fact, what was the whole idea behind part B? What was the whole idea behind part B? Like terms. Yes? You with me? That is all adding, subtracting fractions is. It is just like terms. What's 3/4 minus 2/4? What's 3/4 minus 2/4? 1/4. 3x minus 2x. 1x. So if the thing that it's keeping track of, there's 3/4 minus, now I understand you guys are like, Jeff, it's 1/6. I know, I was making an easier example. 3/4 minus 1/6, are those like terms? That is like 3x minus 1y. You guys see that? So I have to make the bottoms the same, and then I've got like terms. I think if you look at it that way, it might make a little more sense as to why we do the shit we do. So now the next level is, what is the LCD? And the answer is not 24. 12. Here's a cool thing. 6 times 4 is 24. But what number do they have in common? What number do 6 and 4 have in common? What number is a factor of 6 and 4? 2. What's 24 divided by 2? 12. That's the LCD. Always. So you can figure out what they have in common. You can multiply, divide. You can get the LCD. Bam. Yes? There's other ways to do it, and I might do some later. But I know the LCD is 12. So what's this one become? Multiply by what?
Times 3 is 9.
Times 3. So 9/12 minus
2.
2/12 is?
7.
That's insane. 7/12. Good Lord, Jeff. And by the way, if you wanted a teacher that can write well, you have chosen poorly. So this is it. This is how I write. And I tried to use an iPad for a while because I thought it'd be cool to be able to walk around them. It was even worse. So I was like, I'm going to stop now. I'm so sorry. Okay, how's everybody doing so far? What about part D? What's the idea with part D? When I multiply fractions, I can multiply straight across, but what should I want to do first here? Simplify. Because the stuff on the top is doing what with each other? 15 and 21 want to multiply, correct? And the stuff on the bottom wants to do what to the stuff on the top? It wants to divide, correct? So anything that has a common number on the top and the bottom, that common number can die. I don't care if it's over here or over there. Yes? So 15 and 28, they don't share anything. But 15 and 20, of course, share 5. So I can divide by 5, I get 3 and 4. What about, now here's a really cool thing. What's 28 minus 21? 7. So either 7 goes into them, this is not the best example, or a factor of 7 goes into both of them. I don't know if you guys are with me. If I do 3, 6, 9, 12, 15, 18, aren't those all divisible by 3? So the difference between two numbers could tell you what line of multiples they're both in. So in trying to reduce a fraction, you can actually take the difference and figure out, okay, the difference 24, either 24 goes into both, or a factor of 24 goes into both. I don't know if you guys are really with me. Okay. So 15 and 20 are how far apart? 15 and 20. 5. So either 5 goes in, or that's it, because there's no factors of 5 besides 1 and 5. And sure enough, 5 went into both, yes? Okay. So this would be divisible by
3.
7 goes into 21.
That's okay.
28. 4 times. 3 times 3. 4 times 4. Ciao! Yay! Now, somebody I talked to about 8 to the 1/3, I think there's a couple groups I talked to. Does anyone want to explain how to do that one? Yes?
So, for me, the easiest thing, because I know that the 0, anything to the power of 0 is automatically going to be 1 because you can't have a power
So real quick. I don't know if you guys remember, you could rewrite roots as fractional powers. And that's one of my little mini rants, is I wish we never came up with radical notation. It's dumb. If I just had fractional powers, everything actually is easier, believe it or not. We're just so used to the square root, we don't even think about it. When I see a 1/3 power, I automatically know, what are powers based on? What operation? Multiplication. So when I see a 2 up there, that means I want to take 2 of the base. When I see a 1/3 up there, that means I want to take 1/3 of the base multiplicatively. So if you break 8 up into 3 parts multiplicatively, what do you get? 2, 2, 2. So what's 8 to the 1/3? 2. So 1/4 power would literally mean break it up into 4 parts equally under multiplication, and then take 1 of those. You guys follow? Okay. So 8 to the 1/3 is 2. Now, 5 to the 0. I know some groups know what that is. And here's how I explain it. Can you guys remember what x to the x to the 7 divided by x cubed? Sorry. You guys would never know this, but I was actually born in Savannah, so I think every now and again it just bubbles up. No born of Savannah. What do I do with x to the 7th divided by x cubed? Does anyone remember how that works? Yes, because if I wrote 7 x's on top and 3 x's on the bottom, you could cross through 3 of them, yes? So the shortcut is, I'm going to lose as much as on the bottom, so I'm just going to subtract 3. Thank the God we can do that, otherwise x to the 70th would suck, writing x 70 times. Screw that. So I can subtract powers to figure out what it is. Okay, I'm not saying I could write it. So what would x to the 3rd divided by x to the 3rd be based on what we just said?
1.
Based on what we just did. X to the 0. Now, you hit me with it. What's something divided by itself? 1. Yeah. So anything to the 0 power except 0 is 1. 0 to the 0 power, just wait till you get to calculus.
Wait, what?
Real quick. What's 0 to any power? 0 squared, 0 cubed? 0. What's anything to the 0 power?
1.
So what is 0 to the 0 power? It is somehow 0 and 1 at the same time. That's as much as I'm going to say about it. So just 0 makes things freaky. You agree with me? 0 will find a way to make things freaky. 0 to the 0th power is extra freaky. So just wait until calculus. But otherwise, as long as x is not 0, anything to the 0 power is 1. Okay. So coming back to this. This is 2 minus 1, which checks notes is 1. This one, I like the reaction of somebody because this one's sort of a busy work almost. But it's kind of like my example. Do you guys remember FOIL?
Mm-hmm.
Do you guys know what FOIL stands for?
It's like first, outside, inside, last.
I like it. Somebody back there is like, you wrapped that potato over there. In the oven chip. FOIL is dumb as shit. So I have a, if you ever heard of SOHCAHTOA or any of that, I have a lot of rants about these things. When we create stuff like FOIL and SOHCAHTOA, we're making it sound as if it's so hard you couldn't do it if you didn't know this little saying. And that's really silly. If this wasn't here, if just that was there, what would you do? Distribute, correct? So all this is repeated distribution. 2x gets a term, and 3 gets a term. I don't need no FOIL. In fact, FOIL wouldn't mean shit here. Because I have a first and I have an outer, but I also have a middle. So then it would be over my thumb. I don't know if you guys are with me at all. Okay, I'm sorry. I'm a little goofy sometimes. But all it is, all you have to do, take 2x, take it all the way through. What's 2x times 4x squared? 8x. What's 2x times negative 6x? Nice 12x squared. 2x times 9? 18x. Now I'm going to put this on. 3 times 4x squared plus 12x squared. 3 times negative 6x. 3 times 9. Die. 8x cubed plus 27. So I don't know if you guys remember, well, part of what we're going to talk about, and the reason why the last problem is hard, is factoring. And that normally is something students either don't quite get a full grasp on in the first place, or they forget very easily. it is incredibly important. Factoring is just everywhere. So we are going to devote some time to factoring. So this is related to a sum of cubes. And somehow I relate how to factor a sum or difference of cubes. I relate it to the movie Pulp Fiction. Has anybody ever seen Pulp Fiction? Yes.
Mhm.
It's not a prerequisite for the course to have seen it. But there is one scene with some dude in the backseat of a car. It gets a little messy.
Okay.
So I'll talk about it more when we get to factoring. Okay. So between now and then, if you want to, you can watch the movie. Just be careful. It's a little crazy. So maybe don't watch it if you haven't seen it. Now, this is bread and butter of algebra, right? When I say algebra, people normally think of something like this. Hopefully part A wasn't too horrible, but you basically have to pick a side for the x's to go to and a side for the numbers to go to, right? So it's up to you. What I normally try to do is keep my x's positive, so I'm not dividing by negative, because that normally that's another place where us humans can make a mistake, right? I would personally suggest subtract 3x.
That's fine.
But do you have to? No. But if you subtract 3x, it gives me negative 11 equals 2x plus 3. And now I must move to 3 how? What do I do now?
Subtract 3 from
Yeah, subtract 3. And then I can do what?
again.
Divide. Jamal. Yes, sir.
Can I just bring that whole equation over to the other side and just make it equal to 0?
Oh, sure. Yeah.
Okay.
As long as eventually you get the numbers on one side and the x's on the other.
Okay.
You know you're done when you have x equals a number. Normally. There are some problems where all the x's cancel. So we'll talk about that when it comes up. Okay. In fact, did I make this way? No, that one actually works. Damn it. All right. What's the point about this one? What's the first thing I want to do? Distribute. I get what? 2x
Minus 2.
minus 2.
Minus 3x.
Good. I'm distributing negative 3, right? Negative 3x plus 12. Good.
Mhm.
2x minus x is good. Is everybody with me? Distribute so that everything is free to combine with like terms. Yes? Okay. And then what do I do? That one side is done. He's just waiting. What do I do with this overloaded side?
Combine like terms.
Yep. And what's 2x minus 3x?
Negative x
Negative x. And what's negative 2 plus 12?
Plus 10.
Plus 10?
So add x. to
Good.
the side.
Add x.
2x.
You could subtract x, but I would suggest you add x.
And then subtract 4.
Subtract 4. And then you almost always divide last. If you wanted to, how would you check your work?
You just plug in.
Plug in a 3. Because the idea is, whenever this statement is true, then that statement is true. You with me? So let me show you a freaky example real quick. What time is it? Jesus, Jeff. All right, I talk too much. All right, this is a very quick little tiny problem. So let me distribute. Let me subtract 2x. Look what happens. You see what happens?
They cancel.
Negative 2 equals negative 2. When is that true? Is that ever not true? Is negative 2 ever not equal to negative 2? So when is that true? So when is the original problem true? So what's the answer? All real numbers. Any number you plug in for x will work. In fact, this is just freaking distribution. Yes? So does it matter what x is? No. And that's the math can't speak to us. So what does it do instead? The x disappears. And what's funny to me is, as much as students hate letters in their equations, they desperately try to save the x. 2x minus 2x is x. And I'm like, wait, no, what? Let it die. It wants to die. Okay. Cool. Oh, this last guy. Does anyone think they remember how to do that?
No.
So let me ask you this. Is everything in that statement, can you cut it in half multiplicatively? Totally. If I had a binomial times a binomial, I had x and x, you would get x times x is x squared, correct? Do you guys see what I'm saying? Like if there's an x and another x, then I FOIL, I get x squared. So I'm thinking backwards. What did I FOIL in order to get where I am?
X.
There's a middle term missing, correct? So the middle term has to cancel somehow. So x squared is x times x, yes? What's 49y squared? 7y, 7y, yes? So sure enough, when I start to FOIL, I get x squared, I get 49y squared, right?
Yeah.
But I need the middle terms to cancel. So what must be true about the signs? Plus and minus, or minus and plus, right? That's difference in squares. That's factoring. Yes? All right. Let me see if I can push my luck. Normally we're going to take a break and stuff. I think today was okay with all the different ways we were doing things. I'm really sorry for not letting you have a break, but I just want to do one last thing with you real quick while this is up here. What is x and y in this last statement? Do we know? Do we know what x and y are? No. So I'm going to give us, I'm going to say y is 1. And I'm going to say x is 9. Because what could they be? Anything. So I just picked something, right? Out of nowhere. I could have let you pick, but then the numbers might have gotten really gross. Not your fault, but just could. So if what's x squared minus 49y squared then? 9 squared minus 49 times 1 squared, right? What's 9 squared? 81. What's 81 minus 49? You're like, I don't know, man. Just let me go, dude. Yeah. 81 minus 49 is the same thing as 82 minus 50 because they're the same distance apart. Does that make sense? 81 minus 49 is the same as 82 minus 50 because it's the same distance, yes? And what's 82 minus 50? Okay, easy as shit, yes? So when you subtract something close to another whole number, boost both numbers up. Because what's the difference trying to find? The distance between two things. If you maintain the distance, you get the same answer. Okay, so 32. Now, what did we get when we factored the damn thing? Get out. We got x plus 7y times x minus 7y. I said x was 9, and I said y was 1. What is this? This will be 16 times 2, yes? Is that a way to factor 32? You pick any number for x and y, you get a number for x squared minus 49 squared, and then when you plug it into your factored form, you get one way to factor that number. You guys see what I'm saying? So when you factor something with variables in it, you just factored an infinite number of numbers. Do you understand what I just said? Because what could I have picked for x? Anything. What could I have picked for y? Anything. And every one of them will have a number, and then when I plug in here, it'll be a way to factor that number. So somebody's like, what did you do tonight? And you're like, I factored an infinite number of things. What did your ask? Right? Okay, sorry. I think, yeah, we ended 7:30. Sorry, Maria didn't really get a lot to do today, but.
Oh, no, I got my data.
Okay. So if anybody needs to see me for anything, come up and see me. Otherwise, I will see you guys tomorrow. Same time, same place. We'll have a little bit of a tour tomorrow. I will show you at least one really cool thing that I think everybody's going to agree is cool. All right. Get home and get some sleep.